In this short task, we're going to work with some raster data and add it to our map of Rwanda. First of all, we're going to add a raster image to form the underlying base for our map. So in the browser window here, go back to the natural earth data and the section called raster. And you can see in there we have a .tiff file. You can see it's got this grid icon on the left hand side, and that tells you it's a raster if you didn't know from the suffix ending that it's a tiff. So we're just going to double click on that and add it to our map there. Now you can see that it shows you the world in a form of topographic relief, but at this scale it's a little bit too zoomed in. If we zoom out a little bit, at that sort of scale it doesn't seem pixelated. The name also appears in your layers list on the left hand side of the screen, and if you look it up in the folder, so if we look it up here in the folder, and you can see that just like the vector data, that single layer, that single file is made up of a number of different files with the same name and different suffix ending. So this is the TIFF, which is what the computer has actually added, and this is the TIFF world file, .tiffu, and this is what gives the global coordinates of the four corners of the TIFF so that the GIS knows where to put it in its coordinate system. Then we have the AUX XML file and the TIFF over file, and that's how we get the pyramids, which are the cached system for rapidly regenerating rasters. Rasters are quite processing heavy files, and that means that having a cache system of pyramids actually helps your computer to regenerate them quickly. Now, to return to our GIS, if we zoom in a little bit, you will see that although we have the lakes, they are not the beautiful vector lines that we created, but part of the raster. They're all blocky, you can see. That's because the raster has landed underneath the points in the layers list, but on top of the lakes and the rivers. GIS treats its layers very much as a stack of paper, and if there is a layer on top of another layer, you won't be able to see through it unless you have explicitly made that layer translucent or partially hollow. So if I pick that up, and I'm just going to close its layers because we don't need to know its bands, and just move it down to the bottom there, you can see that immediately the rivers reappear, and so do the vector lakes in our light blue colour, and of course the country lines as well. So that's much better. So if you want to see the cells of the raster, you can go up to the zoom button and zoom in, or you can select a suitable scale down here, something like 1 to 75,000 will do it. And you can see that we have these blocks which make up the cells of the raster. And this is why it's such a processing heavy thing to compute, because every single part of the raster has to be covered with data in order for it to function. If we want to see what the data looks like in each of these cells, we can highlight the layer and then go up to the Identify Feature button and click on the layer. And if you click on this cell, you see, what we see is there are 3 bands because it's a 3-band color raster, so the bands are red, green, blue. And each one of them has a numerical value. And the combination of those numerical values is what gives you the color. So the numerical values are essentially the strength of the color within the cell, and the combination of them dictates the color that you see. So it's a mathematical computerized version of what your eyes do in the real world. I'm going to get rid of that Identify Results box now and put it back on the Pan Map button. And you have now finished working with your raster data for the moment.